all to this Wednesday afternoon seminar for RAL. This is a special occasion where we have folks from CISL here to give us an update on some of the cool stuff they're doing. And I hope this can lead to future collaborations. I would also like to say welcome our people online, and to mention this will also be recorded for those who miss it later. So today we'll have a team of people from CISL, and I'll introduce the host of this group, and I'll let him do the rest of the introductions. So first we'll welcome up here John Klein, who is Acting Director of CISL's Technology and Development Division. Also a manager of the Visualization and Analysis Systems Technologies at CISL. I was looking at his webpage. They do a lot of cool work there. And it seems like John's main work is in visualization, wavelets for data sets, volume rendering, and I'm sure many other things. John himself goes all the way back to the Reagan administration, 1987, when he started here at NCAR and got his master's at University of Colorado in computer science. So I'll turn it over to John.
Well, thanks for the introduction, Chris. You managed to cover about half of the things that I need to say before I kick this off and hand it over to the team. So thank you again all for coming today. Really appreciate the opportunity to speak with you all. We're doing something that I don't think we've ever done before, at least since the Reagan era, perhaps, or before. That's how long I've been here. We're calling this the CISL Roadshow. We're basically going out to all of the LCPOs and talking to them about the service, products, and other resources that CISL provides to help support earth sciences. I guess a secondary goal here, and beyond just communicating what we provide, but is also to help build connections between CISL staff and the scientific communities that CISL supports. We absolutely cannot do our jobs effectively if we don't have strong connections with the scientific community, good understanding of what their needs are, and opportunities to work with them. So the format for today, we've got basically a series of 5-minute lightning talks with about 1 minute for questions after each talk. And then at the end, we'll get everybody back up here for about 15 minutes for questions. I apologize now, it is a jam-packed agenda. Some of the slides are quite dense. There's a lot of information. I've asked the speakers to focus on the highlights, but everything that's, all of the slides and even the recording for today are gonna be saved online so you can access them later. So don't be terribly stressed out about not being able to capture the many QR codes and URLs that you're going to see. There's really only one QR code that you'll need to record. It's this one. It takes you to the event website, and we'll show it again at the end when we do Q&A. You'll also find on the website a survey, and that's my one ask of you all. If you could please take a minute or two to complete the survey, we'd greatly appreciate it. That should be about all the time it takes. It's really short. You'll also find speaker bios, slides, and of course the presentation recordings. So with that, we'll get started with our first speaker, Ben Kirk, who heads up the CISL Consulting Group.
Thanks, John. My name is Ben Kirk, and I'm from the Consulting Services Group within CISL's High Performance Computing Division. I'd like to talk a little bit about the HPC resources and access and support forums that we offer. So everything that we're going to show today on the facility side is housed in the NCAR Wyoming Supercomputing Center just across the border in Cheyenne. We definitely love giving tours. It's world class. If you've never been there, haven't been there lately, pop in and see what Derecho looks like. In terms of resources, we have 3 broad classes. The big HPC systems that you're familiar with. Currently, we have Derecho, has over 300,000 AMD CPU cores and over 320 NVIDIA A100 or Ampere GPU accelerators. That system was put on the floor about 2 years ago and has been in full production for 18 months. These systems tend to have a lifespan of roughly 5 years, which means we're already planning for NWSC4, the follow-on to Derecho. This is where large modeling simulation runs, Musica, WRF-Chem, CESM variants, those types of things tend to run. We also have companion resources that are housed in Casper. Casper is a little bit different architecture. It's sort of a condo cluster. It has many different facets to it, including high throughput computing nodes. These are tailored for small, single, or low core count jobs, typically data analysis or visualization workflows. We also have a hodgepodge of AIML tailored GPU resources, so 3 generations of NVIDIA accelerators present, and we're continuously adding to that resource. It also has a number of very, very large memory jobs for post-processing workflows that really demand a high amount of RAM. Now you can find that on Casper as well. We use Casper and Derecho to field a number of services that you're going to hear about today, but principally our Jupyter Hub service and a number of the visualization tools that we develop are provided and hosted primarily on Casper, as well as open source to the community. And then lastly, we have a very large data storage component that connects to this entire ecosystem. Campaign storage is an online disk-based system that's currently about 125 petabytes, and that is for long-term archival type storage, but it is online on a disk-based system. That is connected directly to our Quasar tape library, currently at 35 petabytes, but growing this year. That is offline tape archival, so truly cold storage. And then a companion system that goes along with Derecho is its Scratch file system. This is for temporary high-performance storage that's tied to modeling and simulation runs before it can be post-processed to smaller data sets. That's currently 55 petabytes of Lustre-based file system. So in terms of accessing resources, so compute allocations are the currency for Derecho and Casper. CPU and GPU hours are awarded through the lab managers, and so RAL has a pretty hefty component on both of those systems. Storage depends on which type of storage you're talking about, really. Each user has a direct 30 terabyte allocation on Derecho Scratch. That is the scrubbed file system that files are deleted when they're not accessed for over 180 days. We do have ability within my group to modify those quotas on request for temporary needs. Just reach out through a ticket. We handle that all the time. Campaign storage, the allocation is a little more complicated. It is allocated to the lab and then allocated down to sub-projects. Because we don't purge lab data, it's required that the lab managers keep a tight handle on where that sits at. I think as of a couple weeks ago, RAL had about 15 petabytes of campaign storage data and always continuing to grow. The operations and policy we manage through what we call the Storage Advisors Group, which has lab representatives, including from RAL as well. We also run a number of support forums. We develop user documentation. We handle user support requests through a triage help desk system. We have a Slack channel, which is usually great. Today, Slack's having issues, but such is life. And you'll hear about a number of community-based groups later on in today's session from a colleague of mine, Megan Savani. So with that, let me stop and ask if there's any questions in my 1 minute before we pivot to the next topic. And of course, we'll come back. Yes.
Yeah, thanks, Ben. Just a quick question. So each node on Derecho has about 235 gigabytes of memory. And so that is limiting in some cases where we need probably more memory per node. Otherwise, we have to reduce the number of processors that we can use. So I guess I'm not sure if there is plan to address that on Derecho or in NWSC4 later.
Certainly in NWSC4. It's not clear that we have a really cost-effective way to do that in Derecho's lifespan because of the way the memory is laid out. But we're formulating what we call the SRAP, the Science Requirements Advisory Panel for NWSC4 right now, and that's definitely an input that we've got captured already, but we'll want to get some quantitative inputs from you on that.
Thank you.
So who's the rep in RAL for the SAG group, the Storage Advisory Group?
Trude and Jeremy Sauer spent some time on there as well. But,
Okay, thank you.
Mm-hmm.
And I attend those meetings.
All right, so The next section of the talk is about the Application Scale Building Performance Group. This is a group that I co-lead with Sherry. And so what we do is we enable large-scale computing in the Earth and related geoscience communities. And then we can break this into a couple different categories, enabling breakthrough science through co-design with the scientific community. So this was there's advanced scientific discovery projects that I'll mention more about later. Creating portable, scalable, and energy-efficient codes for modern architectures, optimize I/O input-output workflows, looking at software verification and reproducibility techniques, and also develop techniques to reduce data volume through data compression. And so we've applied these to a number of applications that the acronym SOUP that you see there. This is pictures of our group. I just realized 5 minutes before that it's a little bit old. But one of our focus areas that I want to talk about is GPU-based computing, and so that you can have scientific discovery and reduce energy consumption. I know RAL does a lot of work with the fast eddy code, so they're probably more familiar with this than other sections of NCAR, and it can significantly reduce carbon footprint on large-scale simulations. So I mentioned before the accelerated scientific discovery projects. This is where the system is, when it's initially installed, it's turned over to a smaller number of groups of individuals or projects that focus on big computing problems. We had direct participation in 2 of these. One was solar modeling. And because of the use of GPU computing, we were able to eliminate 4 person years of simulation had we used a CPU-based solution, and microscale atmospheric modeling. Project, mention that a little bit more in the next slide, and that reduced 3 person years of emissions. So this was the CM1 model, and so what we did is we had a 1024 by 1024 by 512 grid. We had up to 1 billion particles, and we did what we were looking at is we were looking at the boundary layer below a hurricane, where waves would inject aerosols into the boundary layer. So again, we, using the GPU, reduced emissions of 47.5 tons of carbon versus a CU-based solution, or a CPU-based solution. One of the other things that we do a lot of work with is lossy compression for Earth system models, and the data generation trends at NCAR are really unsustainable. I believe we've had some, and so you can use lossy compression to reduce storage for both CSM as well as other models, and so this is done through looking at the statistics of ensembles. I believe we've used this. We've had some interaction with RAL with respect to the CONUS data set. And then the ensemble consistency test for CSM development. So when we optimize code for either CPU or GPU architectures, we do tend to change the order of operations, and so we want to be able to identify what are acceptable changes that are from just a different order of summation versus something that's more problematic, whether we perhaps break the code. And so so we look at correctness as statistically distinguishable from the original data. And so this is using an ensemble and looking at the variability within this ensemble. And this is also, of course, used in the previous slide with respect to data compression. So the notion is if you can't tell that the compressed data is outside the ensemble, then you argue that it's not, you argue that it's acceptable. So, so finally to wrap up, there's a link for how to engage with us. There's a web page or a Google Forms that you can fill out, and then just more information about our activities. Any questions?
Quick question. The CM1 with GPUs, is that now a standard version that's available for any of us to use, or is that still under development?
I believe George Bryan is going to release it soon, or he's already done that.
Okay. Very exciting. Thank you.
Yeah. All right. I guess I'll next.
All right. Thanks everybody for joining us today. I'll provide a brief overview of some of the data services that we offer in CISL and look forward to your questions. So I wanted to start this off with just kind of a general overview of the architecture of the data services at NCAR. So the way we're structured, we have a number of different repositories that support different domains of science across this organization, ranging from climate model outputs to the research data archive that really supports data proximate compute, and then observing facilities that maintain their own repositories. So if one wants to come into NCAR and search across all the resources that are available in our organization, they should go to this website called data.ucar.edu, and that's where you can kind of search and discover anything that's held in these various repositories at NCAR. So now I'm going to kind of focus on what we provide in CISL, specifically the Research Data Archive, which has really been in place since the 1960s when we originally had a computational facility to support data proximate computational research. And for those who aren't aware, all of the data sets that are in the Research Data Archive are available under that directory path, Glade Campaign Collections RDA data. And then we have a number of what I call, convenience copies of different collections of things that come in and are produced by outside providers such as NCEP, ECMWF, and JMA. And we also support PI-produced data sets at NCAR, or projects at NCAR, such as the CONUS 404. And if you have a data set that you think would be useful for a convenience copy, please contact us and we can put it on there. One that typically has many users, where there might be many copies of this data set sitting in NCAR, so we're trying to kind of find a better way to do that. On this page, it's highlighting what's a data access tab. When you land on an RDA data set, you get a description, then you can click on the data access tab. But what I really wanted to focus on for this audience is number 3. That's where you can view file locations basically on Glade. So if you're looking at ERA5 or a different data set and I want to know where certain files are that have certain parameters in them, this is basically where you can go find that mapping and inventory. So that's a good starting point if you want to access something that's on Glade directly. Recommend that over downloading the files back into your own Glade directory. And then this is something a lot of users at NCAR have had to learn about over the past several years. It's basically a requirement for PIs, if you're submitting a proposal in response to a solicitation, to go through this process where you have to basically look and see if you need to include costs for data management services. And this is the resource that one goes through for that. And this also supports if you have a data set that you'd like to deposit in a repository to meet things such as publication expectations for making data available. This is the resource you go through, submitdata.ucar.edu, and then you'll be connected with the right people to help you out. Historically, data sets that are less than 1 terabyte in size, CISL's covered the data management services cost, and for larger data sets, PIs or labs might have to cover the data management services cost. We're kind of looking at bumping this up to 10 terabytes right now, so this has been kind of a historical number. In terms of the data set policies, so model output data sets typically have a default lifespan of 5 years that may be extended. So basically there's a process to look at usage metrics, citation metrics after 5 years. And then if something doesn't get a lot of use, we'll work with the PI and decide what's the best course to move forward if we need to continue to support that data set in a repository. The PI has the option to pay for it, look at other mechanisms to do so. If it's an observation that cannot be recreated, those things, go into these archives permanently or indefinitely, I guess, because they cannot be reproduced. So that's really all I had to highlight here. And that's all I had to say. So let me know if you have any questions. Thanks for your attention.
Yeah, thank you, Doug. My question is about, I know the cost is not that low when the data set is very large. Now we have the companion Kronos 4 for PGW data, similar size or the same size as Kronos 404. And the whole community is looking for the access to the data similar to Kronos 404 level. So we are really seeking a solution to make that PGW data available to the community through either RDA or similar portal. Right now it sits on the campaign. We have to do manual ACL to allow users to access data that way. So I know there are metrics to evaluate the value of the data, but given the Kronos 404's popularity, is it possible that PGW can be an exception to get into RDA through some kind of organization level of support?
I think we'd need to, submit a request through this process. Kronos 404 was paid for by USGS for 2 years. That's kind of the process that went through, and then we're looking at statistics, and I think the organization can say this is aligned with our mission to support this project, and now we'll cover it moving forward. But that's kind of the process that happened with Kronos 404. So there was an initial payment, and then we have to just look at our available resources as well. But please contact me. We can definitely, let's discuss. Anything else? If not, move on to Orhan's presentation.
Okay, this stuff is the community analysis tools and visualization services we provide. The Wiser team, led by Nihant, is a team of software engineers, visualization designers, and student assistants who are focused on advanced data visualizations. Wiser has collaborated with researchers, educators, outreach staff, and news outlets so far to communicate NCAR's science through data visualizations. And some of the products they have created so far is including interactive dashboards, production quality videos and animations, and also Vapor. Vapor is an application for 3D visualization and analysis for complex time-varying data sets in the most common geoscience data formats. Vapor has been serving the geoscience community for more than 20 years now, and it's accessible through a desktop application and also a Python API, which was recently added into the stack, and Vapor is open source. This QR code should bring you all to more information about Vapor, and you can also contact Nihant. Also check out the Wiser website if you need any assistance about any advanced data visualization. The GeoCat team, led by myself, on the other hand, is a small team of software engineers with diverse backgrounds in science and development projects. We create a number of Python packages for data analysis and visualization services for ESS, Earth System Science workflows. Some of the packages you can see here on the screen. GeoCat Comp, for example, is the computational component of our tool stack, where we try to implement data analysis functions to realize communities' data analysis workflows. And we also recognize NCL had already put together a lot of common workflows in the past, and a lot of people are transitioning from NCL to the scientific Python ecosystem. So we put together another library, which is called GeoCat Applications, where we support with well-documented examples and indices the transition of people from NCL to scientific Python functionality. You can see an NCL index that shows how each of those NCL functions now can be replicated in the scientific Python ecosystem. GeoCAD examples is a visualization gallery that houses more than 150 visualization examples in essential plotting categories, and some of them are spatial plots like Taylor diagrams. Actually, we noticed some accuracy concerns with curl vectors, so we just put that down from the gallery for now, but it's still there and we are working on it. Moving on, Project Rygene, or the corresponding Python package UXRA, is another direction we are creating functionality for, which is for unstructured grids. We put together analysis and visualization functions to be operated directly on the native unstructured grids from several model outputs such as MPAS, CESM, and all other many other global model outputs as well. And we are trying to create a vibrant community of users and user contributors around UXRA as well. I think this wraps up my 5 minutes, or however much I took. I can take any questions.
No, this is great. And I guess I asked my question coming from a background as an educator. What you're showing in terms of the data visualization tools is something that I think every instructor at a university that teach atmospheric and related sciences needs to have at the ready to advise their students. So in that respect, are you guys working with COMET at all, or maybe develop some sort of education and training modules for all of this that can be distributed to the university
100%.
community?
Yeah, I think that's a great point. Thank you so much. And I would highly recommend to wait for the, I think, very end part of these presentations, which is going to talk about Project Pythia, where we put together a lot of examples and well-documented cookbooks that Negin is going to go over. So yeah, but again, we are 100% open to any comments and feedback so that we can improve all of our existing materials for educational purposes.
Well, I'm saying not just that, but I'm saying, is there a collaboration maybe with the COMET program to get some of these out to the UCAR community?
Existing, John, maybe.
No, but that's a great idea. We should be connecting with COMET, so thanks for that comment.
Thank you.
Okay, next up is data assimilation. I would like to talk to you about the kind of data assimilation tools we provide here in CISL for Earth system applications, especially for the science applications that you guys run here in RAL. So at its core, data assimilation is the process where you combine observations with a forecast from a model in order to obtain an analysis or the best possible estimate of the system. Our team, which is the Data Assimilation Research Section, or DERES, we make it our mission to accelerate progress in Earth system science at NCAR, UCAR universities, and the broader science community by providing state-of-the-art ensemble DA capabilities. And we do that by developing and maintaining the Data Assimilation Research Testbed, otherwise known as DART, which is a community facility for ensemble DA. So DART is an open source, flexible, and freely available community facility for ensemble DA. It has been up and running and serving the community for more than 2 decades now. You can do a number of different things, a number of different research activities in DART, and those range from ensemble forecasting, reanalysis, to model improvement through parameter estimation, predictability and sensitivity studies, in addition to other observation design and evaluation, in addition to data assimilation algorithms. If you'd like to learn more about DART, I put the website there, and if you have any questions, you could definitely get in touch with us. These are the different geophysical models that are interfaced with DART. You see them, they are distributed on the figure according to their functionality in the environment. Every model that's in red is an NCAR based and developed model. On top of the models, these are the Earth system observations that we support. Essentially, these are the platform that provide the observations that we support in Dart. And just to give you a prime example of how Dart can be used and how can it be utilized, especially for the science applications here in RAL, I'd like to talk to you about HydroDart, which is a hydrologic ensemble prediction system that is designed to predict the stream flow and flooding events that are induced by hurricane and torrential rain events. So this is an effort that started almost a decade ago. I myself work closely with the HAB team in RAL here, in addition to other folks at USGS. The system is able to provide hourly stream flow data simulation. It's a highly robust framework, and using state-of-the-art data simulation tools. So as far as the data simulation algorithms that come with this system, over the years we've developed several state-of-the-art algorithms that enhance the stream flow and flood prediction. And these range from adaptive covariance inflation to restore ensemble spread to along the stream localization, essentially how we can localize the impact of observations on the stream network. And recently, the recently proposed hybrid ensemble and variational schemes. And just quickly to show you some results that you can get with this system. So we've tested the HydroDart at different regional sites. We've tested flash floods and we've tested long-lasting flooding events. Overall, we've seen significant enhancement to the prediction accuracy. Right now, we're extending this whole thing to do CONUS-wide stream flow predictions. And I guess the highlight of the algorithm of the system here is that it can provide you with early warnings. And at some sites, we've seen up to 18 hours improved prediction accuracy ahead of flooding peaks. So as far as our team goes, so these are the original ambassadors of the team in Jeff Anderson and Kevin Rader. So the whole thing started in 2003 as an NCAR director's strategic initiative. Right now we are a team of 7 to 8 members, composed of physical scientists, software engineers, and data simulation scientists. We've been working lately on advanced data simulation algorithms that provide unique nonlinear and non-Gaussian capabilities that are particularly useful for science here in RAL. And with that, I'd like to stop and take any questions.
I can ask one. Or maybe you can answer that question.
I cannot see it.
Can you run Dart on GPUs?
Not yet, but we've worked through some hackathons, and we're starting to look into that. Yeah.
Yeah, my question is Dart is computationally very expensive, which makes it challenging for us to implement it for some stakeholders, especially from the developing countries. Do you have any recommendations on how to overcome that issue?
Yeah, so I'm not sure where that expensive is coming from, but we'll be happy to work with you because we've worked with different kind of models from atmospheric chemistry, from weather applications to climate to upper atmosphere studies, and with hydrologic applications. So we'll definitely need to address that, and we'll be happy to talk afterwards. Yeah.
Sure.
Next is EJ.
So somebody from the Miles team would normally give a talk about machine learning applications. Unfortunately, they're all at a hackathon this week, so I'm going to do my best to channel Miles and hopefully keep to the same schedule that all of the other speakers have been able to do. So Miles is the Machine Integration and Learning for Earth Systems group within CISL. They focus on a variety of AI applications from model emulation to uncertainty quantification, feature detection, and a variety of other things. The team it's a small team. but they've got both machine learning expertise as well as some pretty deep domain knowledge in the earth sciences. And they also tend to, I think, punch a bit above their weight because of the many, many collaborations that they have throughout NCAR and the university community. Just a slide of some of the folks that Miles has worked with over the past few years. You can see a number of different individuals and groups. We'd certainly like to see some further engagement with RAL in the future. So, I want to talk about a few recent research applications that Miles has been involved in, starting with credit. I think one of the most exciting, maybe overhyped areas in machine learning and the earth sciences has been the rapid rise of data-driven or machine learning-based weather and climate forecasting systems. In only a couple of years, these things have gone from being something that was plausible to something that is now outperforming by many metrics some of the best of breed physics-based models. So credit is probably better described as a framework than a specific model. It provides the foundations for exploring different modeling architectures. Here they're showing the WEX former architecture and training it with different data sets. The real value add by credit relative to the many other models that are out there is the framework that allows a lot of experimentation, the open source nature of all of the code, not just the model weights themselves, and the fact that it runs well on NCAR HPC systems, and that is no small feat for these large distributed models to get them running on a particular platform. Just some eye candy. This is a 10-day forecast that's coming out of credit. The green and blue are 500 millibar water vapor. Oranges are wind speed, and the contour lines are temperature. Another relatively recent area for Miles has been in inverse problems. This is a collaboration with Matt Heyman in EOL. Holodeck is a airborne instrument that generates holograms of cloud particles. The holograms then need to be processed to tease out things like particle position and size. Historically, this has been done through some fairly computationally intensive physics-based processes. Miles has had some really good success using machine learning techniques to reconstruct the positions and sizes and shapes of these particles. And they're more the ML-based approach is more computationally efficient and in many cases more accurate than what was we're getting with the physics-based methods. And then finally, I'll say something about uncertainty quantification, which is a real important area in many different, across the earth sciences. Typically with large physics-based models, this is done through ensembles. The same approach can be used with machine learning emulators. The disadvantage of using ensembles is the additional cost of running multiple simulations. There's a relatively recent machine learning architecture called enhanced neural networks that allows you to tease out the uncertainty both at the data-driven uncertainty as well as model-driven uncertainty. I said enhances evidential neural networks, apologies. Miles has put together some tooling around this called Miles Guess, and you can see some of the examples of Miles Guess being applied to a number of different applications. So, to wrap up, again, as I said earlier, Miles is a highly collaborative group. They work with a number of different entities across the NCAR labs on a variety of applications in the AI ML space. Love to work with more folks in RAL in the future. There's some contact information here, and again, this will all be available later on. So, thank you. You're welcome to ask questions. I'll probably have to defer, but fire away if you'd like.
Because I remember you saying the AI model is more accurate than the physics model for the holodeck. Is that true statement, or just say they're comfortable?
So my understanding is my recollection is for particle positions, it was about 20% more accurate than the physics-based
That's cool.
approaches that they were comparing against.
Interesting.
Details are in the paper, which is not cited here, but we can find.
All right, thank you.
Interesting. I have a more general question, just because I've fallen behind after not looking at AI for a few months. I've been really impressed by the large-scale prediction of these data-driven models that you were talking about. Are there a lot of efforts now and success with like small-scale extreme-type weather, mesoscale, those types of events?
It's a fair question. I really have no idea. I don't know if anybody else on the CISL team has an answer there, or maybe somebody else in the room.
Well, this is more of a comment, but I think to answer questions like that, I'm aware that Thomas is working on a draft strategic document of like AI and NCAR as a whole. And so the activities that you're reporting are going to be the nucleus of that.
Yeah, Miles will certainly play a part of the broader NCAR AI strategy that's under development currently. So. Okay, well, our next speaker is actually online, Negan Sabani. So hopefully Negan is available, and I'm gonna stand up here and drive the slides for
her. Can you hear me?
Yes.
Perfect. Hello, everyone. Thanks so much for joining us today. My name is Negin Sobani. I'm an HPC consultant working in Consulting Services Group. Apologies, I could not be there in person today due to an ongoing GPU hackathon. We are participating now to just improve data loading for some AI ML workflows. Today, I'm excited to talk about some of the training programs, hackathons, as I'm participating in now, initiatives and communities that CISL is heavily involved in, or CISL lead. And these are good resources in general for our user community to be aware of. These communities and efforts, everything I mentioned today, will be open for everyone to join. And there are created to enable open science and teach a wide range of software engineering, computational science, data science skills to both NCAR staff and the broader geoscientific community. All the communities I'll mention are open for everyone to join. So yeah, feel free to join them. And I have 5 minutes to cover them. I added links for each one of these communities. I will not have the chance to go into details, but please let me know if you have questions, and please feel free to check the links. John, can you please move to the next slide? So the first community I want to mention is NHOG, or NCAR HPC User Group, which many of you are already familiar with. NHOG is a dedicated community that aims to promote best practices and productive use of our HPC facilities at NCAR and increase collaboration among all of the NCAR HPC community. So at NHOG, we have the monthly meetings with different users and different teams providing updates on their workflow, their models, and what they are running on our HPC systems. We also have a community blog that's open for anyone to contribute to share best practices, tips, and tricks on our HPC systems. We also hold different workshops and tutorials. NHOG has different communication channels we have a web page that has the archive of the past meetings, monthly meetings. Feel free to check it out, and the slides from the past meetings are there. NHUG Slack is very active, especially in the past year and a half, and it serves as a platform for our community discussing different topics about our HPC and HPC systems and reporting issues and talking about different models. And last but not least, we have the email list. If you want to receive invites, for example, for future NHUG monthly meetings, please feel free to join our email list. And I added the QR code and the links for all of these in this slide. Can you please move to the next slide, John? Thank you so much. So next, I'd like to mention the SEA, or Software Engineering Assembly. SEA is the UCAR initiative, and CISL is also heavily involved in SEA. And the mission of SEA is to build a community around scientific software engineering and foster collaborations among all of NCAR and UCAR staff, and also the community with an interest in scientific software engineering. So SEA holds ISS conference, Improving Scientific Software. It also holds several community of practice discussions. We have one community of practice discussion on language interoperability happening at 3 p.m. today. So please, and it's widely advertised in staff notes. If that's a topic of interest, please feel free to join it. I also wanted to, if you move to the next slide, John, and just click so that it shows all the information. Perfect. I also wanted to add a shameless plug on the Improving Scientific Software Conference, which is going to happen in April, so April 7th to April 10th. And the topics of this year are, the program of this year has been announced. The deadline for registration is March 21st. If that's something that's interesting to you, please feel free to check it out and register. You move to the next slide. Perfect, thank you. Next is ESDS, or Earth System Data Science Initiative. So I am sure many of you are already familiar with ESDS. And ESDS vision is to advocate and create a community of practice around data analysis, especially for large data set. And it includes both model outputs and observational data set. And I know at RAL, our staff and our scientists are using both observational and model outputs. ESDS hosts a range of different activities. They have forum meetings with different users providing updates about their workflows. And they also have office hours to help with your data analysis workflow. If you move to the next slide, please. Next, I wanted to mention Project Pythia. Project Pythia provides a fantastic resource for anyone who is interested in learning about Python. And it has Python tutorials, it has videos on Python basics and Python introductions to Python. It also includes some cookbooks which has specific workflows, for example, for particular scientific goal. So data analysis using ERA5, blah, blah, blah. So if you have a specific scientific workflow that you are using for example, one of your papers, you can actually easily create a Pythia cookbook out of it and contribute to the Pythia cookbook gallery, which is really cool because when the community looks at the Pythia cookbook gallery, they can look to see if they can find something, someone has done this before in the past, and use that to be more efficient. And Pythia, Project Pythia also holds the Pythia cook-offs, which are hackathons that are created with the goal of first introducing some of the community members to Python and the Pythia resources. And also it would be a good opportunity for anyone who wants to create Pythia cookbook and contribute to the cookbook gallery. Can you please move to the next slide, John? And last but not least, we have a hackathon, the Digital Earth Hackathon, which is a global hackathon being organized between different institutions, and NCAR is one of the participating centers and organizations. In this hackathon, there are several different organizations participating in the hackathon. and NCAR is one of them. So this is organized for May of 2025, and the NCAR site is NCAR's Foothill Labs. I've added, there is a QR code for this event. Please feel free to check it out. And the goal of this hackathon specifically is to improve your analysis of large-scale data analysis codes. They specifically mention kilometer-scale climate models, but large-scale data analysis and improving and optimizing those types of workflows, and also providing some best practices to the community in coding and data-intensive applications and how they can improve the performance on that. So if that's a topic that you'd like to learn about, please feel free to check that hackathon out. And with that, I'd be happy to answer any questions.
I'll just comment that the CONUS 404 data set is going to be part of the hackathon. Questions for Megan, and while you have questions for Megan, I'm going to ask the rest of the team to come on up as well. We'll take questions on any of the topics.
I have a question about the data.ucar edu, especially for external projects where we are required to write open science and data management plan. I understand that maybe we can budget for storing the data for 5 years, but if we have to take the data down after 5 years or purge it, does it really comply with the open science requirement of those funding agencies?
Yeah, so we've looked at what publishers' expectations are, and that's kind of the 5-year timeline, and that's, once again, for model outputs. I think what we've found through a lot of discussions with the open science community is that it's almost more important that you share the code used to generate the data. You know, and there's a big movement basically to allow people to recreate data sets if they're provided with the codes. And the code itself has the logic and really a lot of the science in it that's used to create a data set. So that's, as long as the code's shared, you know, if the data has that 5-year timeline, it can be taken down. Then I'll comment, you know, for some of these other large data sets, I was part of a project that looked at, you know, what really needs to be preserved and shared to communicate knowledge. So these models dump all kinds of things out that people don't necessarily use. So if you want to preserve something, make sure it's the parameters that people really want to access, not everything the model dumps out by default. That can reduce volume quite a bit.
Waiting for the next question, just one comment. This is the one QR code that rules them all. You go to this site and you'll be able to find all of the slides from today and recordings once they're available. You can also reach us by the CISL Roadshow email alias. That'll get to everyone that's presented today and more. And then finally, again, please really appreciate it if you would take the survey.
So I had a question on one of the earlier slides that was going over the HPC services. There was a small comment about hierarchical data management, that was coming. Can you, Ben, can you talk more to that and how that's going to work?
Yeah, so HSM it's sort of a poor man's HPSS, if you remember this, but it's pieced together through 2 IBM products that we already have without additional licensing required. We have the ability to take files that are over 100 megabytes on campaign storage and automatically move them to tape without really user intervention other than putting them in a magic directory. If you have a particular data set that you're curious about, reach out to me and we can run some diagnostics, let you know what the savings might be.
Okay, yeah, I probably will, because we definitely have stuff we're trying to. Will it still count against standard campaign allocations, or would this be separate?
Basically, it becomes inactive on the disk block, so it gets subtracted from your disk quota.
Okay.
But it's only files that are above 100 megabytes, because small files on tape are not really a great idea.
Gotcha. Yeah, I have gigabyte and terabyte level stuff looking to do so. Right.
Hi, this is Elise. I had a question about the advanced visualization for data sets, and I was wondering if, so say down the road I have a simulation and I want to make a really nice production quality visualization of it. Is that, how does that kind of collaboration happen? Does one just kind of approach you and say, hey, I want to do this, or does it need certain funding? How does that work?
I think John might have more insights than me, but as far as I know, Nihan's group, Visor group, has already collaborated with a lot of people from the scientific community to visualize those kind of cases before, and some of them were published and even awarded at different venues. So that said, I am not sure about the funding aspects of the things. Maybe John is a better resource on that one, but I think the fastest way to start such a collaboration is just reach out to Nihant or the Visor group themselves and maybe start the conversation from there. John, would you like to maybe chime into the funding part of things?
Sure. I won't bother pulling it up now, but on the Visor slide, there is a forum that you can go to if you want support for doing a production visualization, something really polished. And the way the team operates is if they have the cycles and they can do it, they try and do it for you. If it's going to be something that looks, it's going to be a substantial lift, they might enter a discussion about maybe being able to fund some of the staff time for doing that. So.
Yeah, I just want to comment on that because I think many RAL scientists have collaborated with many areas in CISL, including almost all the aspects that I talk about. So just by CONUS 4.4 project, we collaborate on data compression, but also visualization. And John's comments, right, you reach out to Nihan and they will provide kind of their availability in terms of how big your scale of work will be. So our CONUS 4.4 visualization activity sort of on they do have a slot of kind of availability, so they want to do it collaboratively without much of a funding support. So yeah, but I really appreciate all the services and the quality of the work. So thank you guys.
Thank you.
Any other questions? Anyone online? Well, we are towards the end of the hour, so I would like to first of all thank you all for taking time to share with us your work. Going through this, it's just very clear. It reminds us like how essential you are to the rest of the NCAR facilities, and also like how much more potential there is for even more synergistic collaboration. So I will encourage many people at RAL who missed this to check this out later on. But I want to thank you again for sharing with us today. And I'm sure people, if you want to talk with these guys afterward, they'll be around. So for a few minutes, maybe. All right, let's give our speakers a round of applause.
And thank